Hello. So in this video, I'd like to talk about supervised versus unsupervised learning. And I know I touched on the concepts earlier, but I want to summarize them because in this week, in this unit, we'll be looking at examples of both supervised and unsupervised learning, and it's important to understand the differences between them. So, the classic buzz phrase is that supervised learning is done on labeled data. Unsupervised learning is done on unlabeled data. So suppose you have a wine data set. We've looked at a wine data set in early examples, so that's why I'm selecting it. And we can talk about, types of wine. I mean, it's a little blurry, but there are white wines and red wines and rosés and so forth. Let's look at two cases. There's a type of wine variable. So in the data set, you've got, acidity and whatever. I'm not a wine person, but somewhere in the data set, you've got a column, type of wine, and you're trying to use the acidity and the other variables to predict the type of wine. Well, this is supervised learning because the information we're trying to predict is right here in the data set. Case two, maybe there's no type of wine variables, but we look at the numbers in the data set and we make the observation that the wine seems to fall into three general groups. We find three clusters by looking at the data. Then, when we investigate, we find one corresponds to white wine, one to red, and one to rosé. So the important thing here is that we're finding clusters, and there's no cluster column in the data set. There's no cluster label. So that's what we mean when we say that unsupervised learning is done on unlabeled data. Sort of directly related to that, we can ask what the goals are of supervised and unsupervised learning. And we've basically just seen this. It's very closely related to the concept of labeled and unlabeled data. For supervised learning, we want to predict something, some labeled quantity using other quantities. So linear regression is the classic example of this. Think back to the linear regression we did, again, using the wine data set. We had a bunch of variables and we had a quality variable, and we were trying to predict the quality variable using the other variables. Another classic example is classification. So we have, a bunch of pictures we're looking at. of dogs and wolves. And this is labeled data. We've got dog labels and wolf labels. And then we've got a bunch of other columns, like fur column and snout length and whatever, and tail length. And we're trying to use all of these quantities to predict what to classify the animal as a dog or a wolf. So, another very classic example of supervised learning, unsupervised learning is discovering previously unknown or unlabeled quantities in the data set. So now you don't have a wolf column, but you have a bunch of other columns, and you do a cluster analysis. You look for clusters in the data set, and you discover two clusters. And then you look at the clusters and you say, oh, these are actually different types of animals. So you're able to discover dogs and wolves using all of this information, even though there's no dog label or wolf label in the data set. So those are pretty absolute. I mean, anything I've said before, you could hammer into a definition of supervised and unsupervised learning. There's not much room for negotiation here. Human effort is fuzzier, but often supervised learning requires significant initial effort. Just because, I mean, again, go back to trying to classify pictures as dogs and wolves. If your, data set, if your training data contains 5,000 pictures, well, somebody had to go through those pictures and manually classify each of them before the data was labeled, before we could let the machine learning algorithm loose on it. Often, unsupervised learning requires requires significant, should I say, terminal effort. So if you're doing unsupervised learning, you can just feed the algorithm the pictures or the data or whatever you have stored, and you can just run the algorithm. No muss, no fuss. But after this clustering algorithm has done its job, you, the researcher, now need to go in and look at the clusters it's found and try to figure out what clusters mean, if clusters mean anything. So nothing on this frame is an absolute rule, but as general guidelines, this is probably pretty fair. Finally, supervised and unsupervised learning vary in how we evaluate them. Um, so supervised learning is very concrete. We have a goal and we can use training and testing data splits. Then we can test the result of the training on the testing data, and we can see how well we met our goal, right? I mean, linear regression. We do the linear regression. Now we have a model that claims it can predict wine quality. Well, you hit this model with some data and you see how well that claim holds up. Or you have a model that you claim can classify pictures of dogs and wolves. You feed that model some pictures and you see how well it does it. Um, because unsupervised learning doesn't claim to be able to make predictions. We can't evaluate unsupervised learning in the same way. Unsupervised learning tries to discover structure and we can use algorithm specific methods to try to see what structure it's discovered, if the structure it's discovered is useful. For example, principal component analysis. We didn't use the phrase, but this is a type of unsupervised learning and we can construct the first five principal components. And that's unsupervised learning. And then we can ask, are these sufficient to explain a lot of variance? Whatever that means. And we can evaluate using a scree plot, for example. So this is what I meant when I said that in general, unsupervised learning is evaluated using specialized tools depending on the type of unsupervised learning. When we get to clusters, we'll talk about silhouettes. That's another specialized way of evaluating unsupervised learning. So those are probably the big points. And as I say, we'll talk about supervised learning and unsupervised learning in this week as a review of things we've already talked about. We've talked about linear regression, which is supervised. And we've talked about PCA, which is unsupervised. So we've seen an example of each of these. Now we're going to see more examples.